Dear aspirants, welcome to my channel. This is a model question paper 3. Branch is Electronics and Communication, semester 2, Applied Electronics. Subject code is 25 ECE21. These are the part C question. So you will get 15 marks if you attend 5 questions. Each question carries 3 marks. And list the 3 types of solid based energy band theory. Write one characteristics of each. In a solid band energy theory of a solids are classified. One is an conductors. These conductors which is having a valency bond, conduction bond overlap and they conduct electricity easily. Coming to the semiconductors, this is having a small gap existing between valency bond and conduction bond. It is conductivity is moderate. Third one is an insulators. The large energy gap existing between valency bond and conduction bond, they do not conduct electricity easily. They does not allow electricity easily. Explain the working principle of bridge rectifier with the capacitive filter. So bridge rectifiers we are use for diode converting AC input to pulsating DC output. AC input converting AC input to DC output. The working principle, coming to the working principle of the diode a bridge rectifier. First, during the positive off cycle, two diode conducts and current flows through a load in one direction. Okay, in a positive off cycle. So two diodes which is do conduct and it current flowing in same direction. Okay. Next is negative off cycle. Two diodes conduct current gain flow in a same direction through the load. And third one, the capacitors connected across the load charges during the peak voltage and discharged during a low voltage, thereby reducing ripples and providing a smooth DC output. That time they are going to conduct the capacitors and large load which is giving a high voltage and low discharge voltage. So it will be reduce the rippling effect and it will give the smooth DC AC current to DC output. Next is described how Zener diode regulate the voltage in a simple circuit. So this Zener diode which is connected to reverse bias across the load resistor, when you input the voltage, it is exceed Zener breakdown voltage. If the input is exceed, that we call it as Zener breakdown voltage, that Zener diode conduct and maintain the constant output voltage across the load. If that and working, first what we have to do, input the voltage increases, Zener current also increases and output voltage remain constant. When input voltage decreases, Zener current decreases but it regulate voltage maintenance. Next, thus the Zener diode act as a voltage regulator. Next, define parameters: drain resistance RD, transductance GFS and amplification factor mu in a JFET. Okay, first we should know what is drain resistance. What do you mean by drain resistance? It is a ratio of drain source voltage to the corresponding change in dry current at a constant voltage. This is the formula for that. Change in VDS divided by ID. Okay. Next is transductance GFS. It is the ratio of drain current, drain current to change the gate source voltage at constant drain voltage. This is the mathematical formula. Okay, drain current transductance. Next is amplification factor mu. We represent amplification factor. It is the ratio of change in drain to source voltage to the change in gate source of the voltage at a constant drain current. This definition you can write. Name the types of amplifying coupling methods. There are different types of amplifier coupling method. One is an RC coupling. Second one is a transforming coupling. Third one is a direct coupling. Fourth one is impedance coupling. And next is describe how CE amplifier configuration achieves voltage amplification compared to CC and CB configuration. So coming to the common emitter, CE nothing but common emitter amplifiers in the CE configuration, which provides high voltage gain and current gain. It gives a high power gain, so widely used for amplifier. Output signals amplified 180-degree phase shift from the input. And compared to CC configuration, so in the CC configuration, high voltage gain, okay, voltage gain near equal to 1 and mainly used for impedance matching. Same way compared to CB configuration provide high voltage gain but low current gain, and CE amplifier gives a better overall amplification than the CB. Okay. Next, explain operation of CE amplifier with the help of input and output waveforms. Okay. In a CE amplifier, input signal applies between a base and emitter, while output is taken by collector and emitter. Okay. Base which input we are taken by base and emitter. Output we have taken by collector and emitter. Same way, a small variation of the base current which cause large variation of the collector current provide amplified output voltage. Okay. Next, output waveforms amplified. Okay. 180-degree out of with the phase of input waves. It will be 180-degree out of phase input. And eighth question, in a CMOS inverter circuit, explain the output state when high voltage applied to the input. How you have to explain? Okay, when a high voltage logic 1 applies in input of CMOS inverter, what will happen? First, NMOS transistor turn on, PMS transistor is turn off, the output connected to the ground NMS, and so that output below become low, logic gate become 0. So if the information is useful, please subscribe my channel, share and support. Keep watching more videos. Thank you.